Hello friends, today's question. A string 2 meter long fixed at its ends is driven by 240 Hz vibrator. The string vibrates in its third harmonic mode. The speed of the wave and its fundamental frequency is. So this question is directly based on the formula. We have to find out the speed of the wave and fundamental frequency. So first of all, let's draw a relationship or write a relationship between the harmonic mode and the wavelength. So we have relation between harmonic mode and wavelength. So for the string which is fixed at both ends, suppose the wavelength is given as delta n and n is the nth harmonic. So we can write for the string fixed at both ends the wavelength suppose that is given as delta n and n is, you can say, for nth harmonic. For nth harmonic it can be written as delta n is equal to 2L divided by n, where L is the length of the string. The length of the string. And in the question it is given that we have to do it, the analysis for the third harmonic. So it means value of n is 3. So we say for third harmonic n is equal to 3. Therefore, we can write that our delta 3 is equal to 2 multiplied by the length. Length is given as 2.0 and divided by 3. And this comes as 4/3 meters. So we found out the length, sorry, not length, but lambda wavelength at the third harmonic. And we know that the wave speed v is equal to frequency multiplied by the wavelength. Wave speed v frequency multiplied by the third harmonic wavelength. Frequency is given as 240 multiplied by 4/3, and this goes by 8, so becomes 80, and we can write this will be our 320 meters per seconds. Now we are going to find out the fundamental frequency which we are required to find out. We say fundamental frequency so it means fundamental frequency which corresponds to the first harmonic, that is value of n is equal to 1. fundamental frequency corresponds to first harmonic that is value of n is equal to 1. So therefore we can write that our f1 will be equal to v divided by delta 1. And we can find out our delta 1, that is the wavelength for first harmonic. Delta 1 will be, let me write it, we can write for first harmonic wavelength delta 1 is equal to 2L divided by 1, because value of n is equal to 1 and length we already know, so we get delta 1 is equal to 2 multiplied by 2.0 and this comes as 4 meters. So therefore frequency f1, fundamental frequency, is equal to velocity we know 320 and divided by 4, and this comes as 80 hertz. So we were supposed to find out two things: speed of the wave and fundamental frequency. So speed of the wave is 320 and fundamental frequency is 80 hertz. So we can write speed of wave is 320 meters per second and fundamental frequency is 80 hertz. So the options that are given to us, option we can see that option number B is the correct option, 320 and 80 hertz. Option B is correct. This completes the question. Thank you.